Okay, let's talk about Section 3.5, system of equations in three variables. As you see, there are three variables in one equation, this case x, y, z. To solve a system of equations in three variables, we need at least minimally three equations with three variables. So here in example 1, I will show you how to solve it. Example 1 on page 284. Solution. With a system of equation with three variables, your goal is to shrink, make the three equations become two equations with two variables. Okay, so right now we have three equations with three variables. Your goal is to change this system to a system of two equations with two variables. Okay, to do that, you need to eliminate one variable. Now, from looking at these three equations, you decide which variable you want to eliminate, either x, y, or z. I would recommend you to pick the one that's kind of obvious that you can eliminate right away. So let's see. Let me call this equation equation 1, this equation 2, okay, and this equation 3. Okay, it's just easy to talk. All right, which variable should we eliminate? Now, look at the first two equations, and you add these two equations together. This z term right here would be eliminated, right? Because this z term has same coefficient with opposite sides. So I will sum up these two equations and shrink these two equations from three variables to two variables. So equation 1 and equation 2, okay? This is n. So equation x plus y plus z equal 4, x minus 2y minus z equal to 1. Let me check. X plus y plus z equal 4, x minus 2y minus z equal 1. I'm adding the two equations. X plus x is 2x. Y subtracts 2y is negative y. Z subtracts z is 0. 4 plus 1 is 5. I'm adding the two equations, okay? Let's check the math. X plus x is 2x. Y plus negative 2y is negative y. Z plus negative z is 0. 4 plus 1 is 5. I'm adding. Now simplify further. You have 2x minus y equal to 5. Do you see that? Start off with the first two equations with start off with two equations with three variables, x, y, z. I combine them and make it become this equation right here, which has only two variables, x and y. Okay, you can call it equations 4 if you want. Reference to this equation, 2x minus y equal 5. Now, so far we just added the first two equations. Okay. Now, if you recall, to solve a system of an equation with two variables, you need at least two equations, okay? So you need to find one more equations that has x and y variables if you want to solve for x and y for this case. So far we combine these first two equations, right? Now let's combine the other two variables. Let me, right here. This time, let's combine these equation 2 and 3, okay? Now, remember when you eliminate the same variable, we just eliminate z, right? So when you combine the next two equations, make sure you keep it the same goal. You eliminate the same variable, which is z. Your goal is to get x and y variables, okay? So I'm combining the equation 2 and 3 to find one more equations with two variables, x and y. That's what I'm trying to do, okay? So, here for equation 2 and 3, equation 2 which is x minus 2y minus z equal 1. This is equation 2. Equation 3 is 2x minus y minus 2z equal to negative 1. Okay? So x minus 2y minus z equal 1. 2x minus y minus 2z equal to minus 1. Remember, I'm trying to find one more equation with two variables, x and y. So that means I need to eliminate the same variable, which is z. So to eliminate this z variable, right? So you need to multiply this equation right here, equation 2, by 2. If you multiply 2, right, you will have negative 2z. But to simplify the z, you need to have same coefficient with opposite sides. So for both negative, if you're adding the two negative, you're not really canceling it out because it does not have the opposite side. Just like 2 subtract 2 is 0, 2 is positive, negative 2 is negative. So you need opposite sides of the same value if you want to get 0. So to do that, I will multiply. Okay, I will multiply both sides by negative 2. Okay, I'm multiplying by negative 2 on both sides. Okay, let me label this a little bit further, not in the way. This is equation 2, and this is equation 3. Okay, my goal, the reason I multiply by negative 2 because I want to get positive 2z. If I have positive 2z, when I add with negative 2z, it becomes 0. Remember, I'm trying to eliminate the term with variable z. So after I multiply that, and let me use braces just to show the thought process, okay? Or brackets, doesn't matter. So for this one right here, I have multiplied the first line right here, which is equation 2. Negative 2 times x is negative 2x. Negative 2 times negative 2y is positive 4y. Negative 2 times negative z is positive 2z. Negative 2 times 1 is negative 2. Remember, when you multiply a constant to an equation, you need to multiply on both sides, okay? That's why I multiply negative 2 on both sides. Alright, now equation 3, just rewriting. I didn't do anything. I did not change it, so it's exactly the same as the original equation 3. Subtract y subtracts 2z equal to negative 1. Alright, first negative 2x, 4y plus 2z, negative 2. For this, 2x, negative y, negative 2z equal to negative 1. This is called a system of two equations, okay, with three variables. Same thing here. It's the same system. I just multiply negative 2 to the first row, okay? Now, so we'll see if we can't eliminate the variable z now. Look at that. Positive 2, negative 2. Same value, opposite side. That means, but when you're adding the two equations, the variable z will be eliminated. Alright, let's add them. Negative 2x plus 2x. Look at that. Not only that you eliminate the x, okay? So this becomes 0. 4y subtract y is positive 3y. 2z subtract 2z is 0. Negative 2 plus negative 1 is negative 3. Simplify 0 plus 3y plus 0 is 3y equal to negative 3. Okay? And to solve for y, you divide both sides by 3. So y is equal to 3 divided by 3 is 1. 1. Okay? Negative 3 divided by 3 is negative 1. 1 times y is y. Y equals to negative 1. Okay? So this is the first variable that we just saw, y equal to negative 1. We're not done yet. The answer is supposed to be 1 for x, okay, something for x here, something for y here, something for z here. We solve for y, so y is negative 1, okay? Y is negative 1. We need to solve for x and z, alright? So I'm going to erase this, knowing that y is negative 1 right here, okay? Let me copy this, and let's call this y here, okay? This is at the end, alright? This is at the end. We're looking for what is x, what is z. Let me take this out of the way. Alright, now we need to solve for x and z. Look at the equation 4. It has x and y. We know y. Can we solve for x? Yes. So for the equation that I call 4 right here, 2x minus y equal to 5. This is equation 4, okay? Substitute y equal to negative 1 in here. Okay? Simplify, we have 2x negative subtract times negative 1 is positive 1 equal to 5. Simplify by subtract 1 on both sides. 2x plus 0 equal to 5. 5 subtract 1 is 4. 2x plus 0, 2x equal 4. To solve for x, we divide by 2 on both sides. 2 divided by 2 is 1. 4 divided by 2 is 2. 1 times x is x. X equal 2. So we just found another variable, which is x equal to 2. So you fill in this space right here, x equal 2. Okay? Now the last variable we need to find is z. Okay? So let me check this out. The way on the side I write x equal 2 here. Okay? Alright, let's solve for z. Now, so far we have equation 1, equation 2, equation 3, equation 4, okay? We need to solve for z. We know x and y. We cannot use equation 4 because there's no z here, okay? So don't use equation 4. There's no z variables. How about these 3 equations? It has z, right? So you can use any of these equations, any one of these equations. Remember, you know x and y. You know x and y, you can solve for z. You just need to pick one equation. I always recommend you pick the easiest equation, the simplest. Look at these 3 equations. Which one has the simplest form? Meaning less coefficient, less negative side, okay? Or the number is smaller. Look like equation 1, right? Plus plus. There are no coefficients. So I will pick equation 1. X plus y plus z equal to 4 to solve for z. This is equation 1, okay? Knowing y equals negative 1, I can substitute for y right here. Knowing x equals 2, I can substitute for x right here. So substitute for x, which is 2, plus substitute negative 1 for y, plus z equal to 4. Simplify 2, subtract 1, or 2 plus times negative 1 is negative 1 plus z equal to 4. 2 subtract 1 is 1 plus z equal to 4. To solve for z, we subtract 1 on both sides. 1 subtract 1 is 0 plus z. 4 subtract 1 is 3. Simplify z equal to 3. Okay? So you have z here to fill in the order pair right here. Actually, this don't call it the order pair anymore because it's not a pair. So this is called 2, negative 1, 3. And this is the answer for this system of 3 equations. Okay? I believe they call order triples because there are 3 variables this time. So this is how you solve for a system of 3 equations with 3 variables. The goal is to change 3 equations to 2 equations, okay, with the same variable x, y, so that you can combine and solve for x, y first, okay. You see, I solve for x, y first, then you use x, y to find z, okay. So again, this is the answer. And you can check this answer by substitute 2, -1, 3, mean x equal 2, y equal -1, z equal 3 to any of these 3 equations. As long as after you substitute for x, y, and z, this equation still have the left-hand side equal to the right-hand side. That means the solution you obtain is correct. If you substitute x equal 2, y equal -1, z equal 3 into this equation, and you don't get 4 on the left, that means this solution is not correct. You can check quickly, right? 2 right here, plus y, what is y? -1, so 2 minus y, mean 2 subtract 1 is 1. So what is z? Z 3, right? So 1 plus 3 is 4. Do you see that 4 equals 4? That means this solution you obtain is correct. And guarantee, if you substitute this value for the second equation, third equation, you still get the same relation where the left-hand side equal to the right-hand side. Okay? So this is the solution for this system of 3 equations with 3 variables.